Welcome everyone to the May 2020 Integration Down Under. And it's funny, I'm sure that everybody like me has been spending lots more time doing Zoom meetings, team meetings, everything online because they're at home staying isolated. And you probably can't see it, but I've got a nice isolation beard in progress. It hasn't started itching to the point that I had to shave it off yet. There's Martin. So let's go ahead and get started. So tonight, we'll go quickly through the organizers. We've got Martin in Perth, Dan in Brisbane, Renee in Sydney, Wagner in Auckland, and myself here in Melbourne. But again, like I said, with the isolation, it doesn't really matter where you are, you're online. So the presenter tonight is Wagner, and he's doing API management, advanced policies, tips and tricks. So without further ado.
Good night again, everyone. The topic for tonight is API management, advanced policies, and some tips and tricks. All right, let's go quickly about who am I. My name is Wagner Silveira. I'm the principal integration architect at Theta. I'm also a Microsoft Azure MVP, and like some of the other organizers, like really focus on integration, although today or these days integration is everywhere. So we end up working with a lot of other stuff around Azure. And that's why API management kind of fits, because it's a way to glue all of that. I'm also the Cloud Platform and CSE, organizers of one of the user groups in Auckland called Auckland Connected Systems User Group, which is like a really old user group related to integration, and one of the co-organizers for Integration Down Under. If you're interested to get in touch with me, you can use my email, wagner.silveira@node2self.tech, or you can reach me on Twitter anytime with WSilveiranZ. And if interested in some of my musings, you can go to https://node2self.tech, and you have some information there. Let's go quickly through the agenda today. What I'm going to do is just a quick API intro, right? And for those that doesn't use to the term, AP is like the nice nickname for API management. So in one slide, just say what API management is. Then we're going to talk a little bit about what policies, why they are important inside API management. Talk a little bit how the policies are executed, so you understand like where you can inject those policies and what you can do at each one of those levels. Talk about policy expressions, what they are, why they are important, how can we use that. And then start with some tips, tricks, and samples on how to use some of those policies to achieve some other stuff. Then finally, some takeaways. Okay, so API management in one slide. The whole idea of API management is get people that has APIs to publish and people that want to consume those APIs, the application developers, to talk together. Usually, those API publishers is going to be creating code and APIs hosted on a lot of stuff, including Azure, right? But it can also be on-premises, can be in other clouds, can be on Kubernetes. So they created those APIs. And on the other side, we have application developers that is creating first parties and third-party applications that want us to use those APIs, but they don't have a way to access that. So that's exactly what API management sits. It's like the block in the middle that is going to connect those two, right? So what it provides for the API publishers, they're going to find a way to both design and publish those APIs in a safe way, using either the Azure portal and today the Visual Studio Code. From the application developers, is going to find a way to consume those APIs before it's actually go to runtime. So understand what is the API capabilities, test, make sure that they know how to use that before they actually get that and apply those APIs into their applications. And finally, when those two things meet together at runtime, we're going to have something that mediates the calls between the first party and route the calls into the backend systems in a safe way. So if you think about the API management, you're going to have basically those three components, and each one of them is going to be using at a certain point, depending on who you are or what persona you're using. A big part that mediation that we're talking about is based on transforming or changing the code or the requests, or blocking certain requests to come to the backend. And that is what policies are, right? So the policies encapsulate a set of common API management functions, like access control, protection of the API, transformation, caching, throttling, and things like that. They are chained together like a pipeline. People that came from the old Beanstalk world is going to get that concept, because we're talking about is a set of commands that are chained together to achieve a result. And in this case, it has a similar behavior like with Beanstalk, because you can talk about the behavior when the message is coming or when the message is coming back or going out. It's going to mutate the request and response context or change the API behavior depending on the inputs that it receives, right? And can be applied at a variety of scopes. We're going to be talking about the scopes in a minute, but you can apply that to a whole API or just to an operation or to a group of APIs together. And as I said before, it can be set in both in the inbound, so when the request is received, or on the outbound, before the response is sent back. And the other thing that is interesting, it can also be triggered on errors, right? So you can have a special way to treat the errors that you receive back from your system, or the errors that happens during the processing, internal processing on API management. So as you can see, policies can be quite a powerful way to change the behavior from your request on the one side and your responses going back. If you're thinking about how those policies are executed, let's think about those scopes that I talked before, right? So we have a number of scopes. We have like the global scope, and that global scope means the whole API management instance that you're hosting on Azure. You can create policies that applies to any API and any group of APIs that are inside. You have another scope that is a product. And the concept of product in API management is a group of APIs that are bundled together, right? Like literally like a product that you're selling or that you're providing to users. One thing interesting inside products is that the same API can belong to multiple products. And that means that if you apply policies at the product level, you can change the behavior of the API depending on which product there is. So next in that scope is the API, right? So you can, as I said, a product is a group of APIs. So you have now one API. And an API is nothing more than a group of operations. So you can see that you have a little level of granularity here, right? You can work on policies that are specific to an operation. You can work on policies that are for an API, policies that are for a product, and policies at the global level. If you get an example here, you can say that the cores and the log policies are applied at the global level. So everything on that instance related to cores and related to log, it's only created once and applied to everything that is underneath that. Rate and quota limits for API depending on how the user, what kind of subscription the user has for your product, can be applied at a product level. So you can have, for example, a product that is your demo product or your test product. And in there, you're saying that you have like really aggressive rates and quotas. People can use it like 3 times a minute and the maximum 10 times a day or something like this. While on your full premium product, you can say that my rate is 0. So I don't actually have rate and quota. You can use as much as you want the APIs that are belong to that product. So you can define those things differently. On the API, as an example, we can have like JWT token validation. So for that API, you can manage authentication and authorization at that level, applying to all the operations. And inside of a specific operation, you can have cache, you can have URL redirections, you can have body changes. What typical example here is SOAP service on a backend that you wanted to modernize and provide as a REST service. You can receive the REST call and convert that REST call into a SOAP call inside that specific operation using body transformation policy. And you can see that in here we're talking about from the caller to the backend and from the backend to the caller back. So you have inbound policies and outbound policies, plus something quite specific to the backend that is call the backend. As an example, you can see if I get like a get full bar on this with that key that indicates a subscription to a product, you can see that the key would be applied at the product level, so you could identify there which product is being used and then apply the rate and quota. You can then see that the /full, that is my API, is at the API level, so I could apply the JWT token at that point. And /par is the operation on that case, and the cache URL and body would be applying to that. And this is how I thought about those policies for a long time. That is like things are applied at that level and that's it, right? But one thing that I discovered recently, or that I just realized recently, is that actually when you're applying this set of policies, you're always going to be applying at an operation level, taking in consideration everything else that comes together. So you have the concept of an effective policy. And the effective policy is, here is a collation of all the policies created at all those levels that applies to that policy, to that operation on that API with that product. Now put everything together and apply that on runtime instead of jumping through hoops and applying those things at different steps. That is going to be interesting because you'll be able to reference products and APIs and operations together on policies, no matter where you are on that list. And I'm going to show you an example of that later on. The next concept that is interesting is the concept of policy expressions. So what is a policy expression? It's basically a set of C# snippets that you can use inside a policy, right? We're going to see that better later on, but on the background here, you can see that I have a whole lot of things in XML, but then after that, we also have a whole lot of things in C#. And that is kind of a representation of an actual policy that we're going to take a look later on. So those C# snippets actually have read-only access to a set of requests, to the request context, right? What that means, it can read certain parts of the request, like the body, the headers, what product is belong to, what are some of the variables that are available at that point, and that allow you to work with this, to play with the context and maybe do conditional executions and things like that. Those C# snippets cannot simply use the whole .NET framework, but there is like a wide list of .NET types and .NET components that you can use. And that list can be found on Microsoft Docs. When you jump into the demo, I can show where you can find that list. The idea here is that you can use those snippets to dynamically configure and conditionally execute policies or route execution depending on the results of those policies. The other thing that I found recently as well is that you can actually include some of those snippets inside the name values. So name values is another concept inside API management where you have a table of name values that you can store with your instance, and you can access that from policies. We're going to be using that on some of the examples that I'm going to show you, and you can touch base a little bit on this. But the interesting thing about this one is you can actually write a name value as a policy expressor. That means that something, for example, like current date, you might need to apply that every time that you need inside the code. You can just represent that as current date, and when it runs this, it pick up the policy snippet and put it inside your code. So we can take a look at that later on. With that, I was just trying to give you like a little bit of context of what is API management, what are the policies, and what are policies expressions, because now that we're going to be talking about tips and tricks, we're basically going to spend the rest of the talk looking at some of the samples that we have and working around why we use some of those policies and how those policies can be reused in other places. Okay, so let's talk about tips, tricks, and some samples. The first tip that I found quite useful is there is a cache policy. And the first thing that we think about a cache policy is, okay, I'm going to be caching my results, and then next time that someone calls it, I don't have to go all the way back to the backend and execute it again, right? But you can use cache for more than just store results from the backend. You can also use cache, for example, to store things that you created dynamically during the request, so you don't have to do that again and again, especially because you're talking about computation. One typical example of that is I can create a SAS token programmatically, and sometimes my backend system is going to require that SAS token, right? So instead of going and creating that SAS token with every request, I can store that SAS token on a cache and only recreate that SAS token again when the cache expires. Right? We're going to have a similar example here with the generation of JWT token. Which brings me to the next tip. You can use policy expressions to dynamically create content during runtime, right? So the SAS token is not something that you can actually store, it's something that you have to calculate. So you can use policy expressions to do that. You can also use policy expressions, for example, to verify the content, the current request against some other data and validate this and decide if you're going to be moving forward or not. Third tip on that one, and then we can see an example that is taking all those three together, is you can execute other calls than just the backend request, right? So if you needed to get data and that data requires another HTTP request, you can do that when you're calling when you're calling the API management operation, you can do an execution, bring back the data, if required, enrich the current content with that data, and then pass it on to the request. A typical case for that one is my backend system requires OAuth, for example, but my front-end system doesn't support OAuth, but it allows me to pass in a subscription. So I can go and generate a token on behalf of that application or on behalf of that user, generate the token and pass it back. Okay. So with that, we can see that demo that is acquiring a Oauth token before calling the backend. Going to stop this for a minute. Can you guys confirm that you see my Visual Studio Code now?
Yes, we can see it.
Awesome. Okay. So before I go and talk a lot about the policies itself, one thing that is kind of tip zero here is inside Visual Studio Code, now you have an API management extension, right? If you go to extensions, you can find that Azure API management extension. And that will allow you to have programmatic access to all your API management instances inside your subscriptions, any subscription that you have available with the username and account, right? And from here, you can actually see all your APIs. You can see your policies. You can see your name values. And you can see your products, right? And inside the APIs, each one of the APIs, let's get the one that we're going to be using. I can see my operations and the policies associated to that. So just to prove the point here, just let me open this one. As I said before, you have policies at different levels, right? So in here, you can say that at the W Silveira and Z consumption, I have a global policy, and I could look at have code on that policy. At each one of the products, I can have policies, and that one, for example, has some code inside those policies that we're going to look at later on. Right? At the API level, the same thing. I could have policies here, or in my case, what I have is a policy at this login operation, right? And if you look at that one, you have a lot of things. Just question to you guys, is the size okay? Want me to increase it a little bit, the font?
Could help if you increase a little bit, yeah.
All good? Okay, one more. Right. So what we have in here, first, as we said before, you have each one of the policies has 3 blocks. We have an inbound block, right? That means that when you receive any request before I send to the backend, I have a backend block, and I have an outbound block, plus an on-error block. So with that, I can define a concatenation of policies or a group of policies at each one of those levels, and they're going to be executed, putting all the inbounds together from global to the operation, put all the inbound together, executing the order that they are, right? Put all the backend together, put all the outbounds together, putting all the on errors together, and as you executing on the order that it becomes. That's why we see that idea of base here. So if you wanted something to happen before whatever is on that group happens, you put it before the base. If you want it to happen after what was on the outer bubbles of that picture that I showed before, you put it after the base. So that also allow you to kind of short circuit some things, and depending on the case. For example, if you wanted by exception to execute something that has been set up before on the product and you are an API, you can put it before the base for that. But most of the cases, you're going to see something like this. You're going to see the base, that is everything that is coming before, and then your code. Now, talking about those samples that we're talking before, on that one, you can see that I'm creating a cache lookup here. I'm saying, hey, do I have a key called beta token inside my cache? If not, if so, put it on the beta token variable. Then now I'm doing using another policy that is a conditional execution, a choose. When my variables contain beta token, and it's only going to be contained beta token at this stage if that cache lookup has the variable, if the cache contains the beta token key. So if you have that, sorry, if I don't have that, if not, then I'm doing a set of things here. The first thing that I'm doing is actually I send in a request to a different operation, not to my backend. I send in a request to something else, right? So what I'm doing is send a request to this URL using this method, setting this header and setting this body, right? So doing a call to a authorization server. And if we come here and look at my name values, I'm going to have something called Oauth server authorization server. I need to refresh this. There we go. Oauth server authorization server. And if I look at the value is the login, the token endpoint for my tenant, right? So after I send that request, I setting the access token to the value that comes of the response. I setting the bearer token to a very specific item inside that result. I setting the token duration in seconds from the spiralizing from that token. Then I store the bearer token inside the cache with that duration. We just have that twice. So ignore the second one, was probably me adding that. Then, now that I have this, I can do a call to my backend with an authorization, setting the authorization header with a bearer with that value, right? So you can see that I basically didn't use almost no code here, apart from inspecting the results. But I also use the cache as a way to store data that is going to be required on the input instead of required on the output. And I managed to do a call to a totally different URL from the URL that I needed for the this actual endpoint, which is just a post bean. Okay, so just to see if how that works, what we're going to need is, first I'll need to create a post bean. Bear with me. I'm just going to create a post bean. Then on the portal for that API, I'll just change the location of that post bean, right? And it's not that the post bean requires Oauth, but I'm doing that just to show that we generated a JWT token, and you have a way to see that on the other side, okay? So now that we see all of that, just let me see one last thing here. On this one, I'm just going to add that API because I don't think that API is anywhere yet. Okay. So now my product contains that API, and then I'll be able to call that. And the way that I'm going to be calling that is another trick here. If I click on test that operation, I'm going to be sending this. This API actually doesn't have any body, right? And I'm just going to replace that just because I didn't get that subscription key set up properly. I have high privilege key. If you guys copy that, please don't. But anyway, I'm going to be cycling those keys anyway at the end of this. And if I send that request and everything works as expected, I should receive a 200 OK back. That means that it went all the way to the end and came back. And my post bean should have a call now that is coming from that login, right, from the W Silveira consumption, and I have an authorization bearer here. If I copy this and go to jwt.ws, you can see that is a valid JWT token is coming from that tenant, right, with all the information from the token, right? So it generated the token. And if you look at the token is EYJ0, right? Starting with EYJ0 and with Z something here. So we can keep that one. If I do another call, should take less time. There is the other one. And we have the same token, EYJ0, EYJ0, etc. Right? So it actually cached the token. So that was the first set of the first set of tips and the first demo done. The next tip that I think that's interesting is you can use the product or the product scope as a way to provide conditional input to APIs, right? So on that one, the idea here is because the product is the encapsulation of a number of APIs, but those APIs can belong to multiple products. If you needed to give information to the backend service, but that information is based on if I'm on product A, I need the backend service to behave in a way. If I'm on product B, I needed the backend service to behave in a different way. You can actually inject that information that you needed to pass to the backend at the product level instead of doing like if from where I come in at the API, right? So the example that I have here is something that we needed to do in a client some time ago. We have an API that was supposed to be logging some information for an application, but not logging the information for a different application. What we did is getting those two applications with different products and just inject a header on the way in at the product level to say, hey, when you pass through this product, inject this header, like log enable, for example, and go through. If you come through this other product, then inject the header with the false value, or don't inject the header, or delete the header if it comes, right? So with that, you, instead of doing if I'm coming from point A, do things in each one of the APIs, you can do that at just one place at your product, which is the demo that I have now, which is quite simple. It's inject product-specific headers. Let's see what we have here. So just to set the scene, so I can close this. Just setting the scene, I'm going to go to logic apps because it couldn't be demo without some logic apps somewhere, right? And that is wrong place. Resource groups, integration down under. Much easier. So on that one, it's going to simulate a conditional log. And what the logic apps does, when it receives a request, it's going to reply with a very sensitive response, hello world. But if I have a header called log enable, and that is set to true, then it's going to log, right? It's going to be creating a compose with the body information. If not, then it's going to do nothing. Okay? And if you go back to Visual Studio Code and looking at the conditional log here on the manual invoke operation, which kind of shows, just let me close all those things. I don't want to save. I don't want to save. Okay, so if I click on the policy of that manual invoke, there is nothing much here apart from set the backend service to the logic apps endpoint. Okay, but if I come into my high privilege product, in here, what I'm doing is just including a header, the log enable header. And on the way out, if I receive that, that header, I'm just removing it. If I look at my low privilege product, right, I don't have anything here. So if I now come to that one and call it, And again, what I'm going to do on this one is first I'm going to be calling it using the high privilege key. Right? And I'm not even going to put any body here, just show you that logic apps is hitting that and going to the compose. Okay? So if I call this, I should be receiving the hello world, all good so far. But if I come into here and the gods are with us, I should be see that the expression result was true and it hit the compose, right? So it received that header. I didn't put the header when I was calling the endpoint at all, right? The only header that I have on those calling was the content type, the subscription key, and the trace. It injected the header. And just to prove that that's the case, if you look at the request for the headers, I have a log enable header call through. Okay? So now I'm doing the same request using the low privilege key. And execute that. The response should be any different, right? I just received a 200. But if you go to the logic app on my backend, the one at 943, the response was false, so it didn't hit that item. And if we search here for the key, we don't have log enable at all, right? So that was a simple example, but think about the possibilities that you have there. You can inside your product not only deal with rate quotas, but I actually manage the behavior of your backend system in a simple way and in a way that is quite easy to deal with by inserting a set of keys there. And with the next example that you're going to see, you can see that you should be able to do that for specific operations if you want to. So back to the presentation. The next and last tip in this case, the policies are always executed at operation level. That's what I was talking before, where I'm going to be first identifying what is the operation that I'm going to execute. I'm going to get the effective policy of everything that comes from that operation, the API that belongs, the product that I receive the key from, anything on the global, put all of those things together in order. And that is the execution of the policies, right? Because of that, that means that every time that you are, doesn't matter where you write the policy, you're always going to have information about what is the API that you're trying to execute, what is the operation that you're trying to execute, what is the product that call that operation, etc. Right? Which means that with this, you can conditionally execute things or validate and vet things in any one of those levels, knowing the full context. So the example that I have here is the example that I wrote a couple of weeks ago in a blog post, is dynamically authorizing an operation based on which product it comes, right? So if we go back to this to set the scene a little bit, what I have is a API called privileged API. Close all of those things. Too many things here. No, don't say. Cool, nice and clean. So the privileged API has 3 operations. It has one that have all access, has one that has low privilege, that one that has high privilege, and that one that has unregistered. So it's brand new, it's still in development. No one should be accessing this, right? On that one, what I want to say is only my high privileged product has access to those APIs. Only my stuff that is marked for all is fine. Stuff that is marked to low and high is fine, but you can granularly define for each operation which product or products can be executed. That's my end goal, okay? And for that, the way that I managed to get this was creating a policy at the API level, right? That says, first, I'm removing my key just because it's good practice. I don't want it to push that to the backend. Let's get that a little bit bigger. Doesn't go more than that. Right, so first I set in a variable called my product, and that is coming from the context.product.id. So I'm on the API, but I have access to the product. And that's okay because in theory, I already passed the product barrier, right? Also, I'm setting a variable called operation rows that comes from a name value. And that's we're going to be looking at in a minute, is a map to say for each one of the operations on this API, which products does it allow. Then I finally set in a operation allowed as some actual code, right? And I say by default is not allowed. Then I get in the product ID, I get in the operation ID, I get in JObject of that operation rows variable. Then the first thing I'm doing is do this JObject array contains a key called with the name of the operation, with the name of the operation ID. If yes, then let's evaluate. So find the list of the element associated to that specific token, break it down into a list, and see if I either have the product name of that list or if I have all on that list. If one of those conditions is true, then I have the response allowed, right? Then now, at the end of this execution here, I have either operation allowed as not allowed or allowed. Then what I can do is choose, right? And my choose is when the condition that variable operation allowed is set to not allowed, then immediately respond with the 403 operation not allowed for this product. Otherwise, just let the rest of the process complete. And the rest of the process is actually the process of each one of the operations, right? So if you look at here, each one of the operations also have its own policy, and the policy on that is just returning a code to run 200 and saying what is the product ID that is being called. Right? And all of that. So just before we test that, just let me show on that name value, how are we dealing with the rows? So if I added that name value, get this, put in a new file, and Ctrl-Shift-V, nope, pretty JSON, the whole thing. Yay. So here I have the all access operation, that is the ID of this operation is marked to all. The low privilege operation, that is this one, is marked to low privilege product and high privilege product. And the high privilege operation is only to high privilege. And I don't have any information here about unregistered, right? So let's see what happens when I run this with the low privilege API. So first I'm going to be called this one. And I'm going to get the low privilege key. So if I send this, yes, it's okay, and I receive it from the low privilege product, okay? If I do the same thing coming from the high privilege key, from that different product, then yes, it's working, and it came from that product. Now, if I try to run high privilege, oh, I hate when it does that. If I try to run high privilege, because we know that low privilege allow both, using the, I'm not going to jinx, I'm going to copy that again. Using that key, if everything goes right, I should receive a 403. Is that okay? 403 operation is not allowed for this product. If I use the other key, then all good. And finally, if I run the high privilege, wrong place again. And in this case, doesn't matter what key I put here, right? I'll start with the high privilege. Unregistered API. Sorry, just in the wrong place is kind of a mess here. Much better. I try to run that one with one of the keys. I receive a 403, and even if I try with the other one, I receive a 403 because that one is not on the map, right? So again, just to come back to the presentation, the idea here is on that example is that you can access information from products, operations, APIs, and in theory, even the global settings. Doesn't matter where you are on your set where you write in the code, because because of the idea of the effective policy. All those policies are going to be putting together first to find out what is the effective policy that are going to be run. And at that point, the context knows what operation ID you're running, what product ID I am, what API I'm coming from, all that kind of information, right? And that also means that when you're talking about injecting data from the product point of view, you can take in consideration different operations or different APIs and things. So you can make those rules that I did there a little bit more complex because you have all that information available. So that's basically what I had to show you guys today, right? As some takeaways, I think I showed that the policy expression is a very powerful tool, right? So the idea of being able to actually inject C# code and code some stuff that would be really hard to do with XSLT or some of other things, or that actually doesn't even have to do with the body of the message, but with the whole context of what is coming, can make API management a really powerful tool. The other thing that you like to take away, that the idea of the product policies allow you to conditionally inject policies in an API, right? So there are things that are not on the API, but can become part of the API if they're coming from product A or if they're coming from product B. That was fine for, we knew about that, for example, the rate limits and the quotas and things like that, but this can be pretty much anything because of the idea of the effective policy that we talked before.
Thank you very much, Wagner.
Cool. The last, yeah, I have a couple more.
Okay.
Mm-hmm. So the other one is, although policies are written at different scopes, right? They are always rendered first and put together at operation level during runtime. So you can write things at different levels and they're going to be executed together. Because of that, write the policy at the highest scope possible to avoid having to write policy code twice, right? On my first iteration of that code that you look at that, I tried to write that for each one of the operations. And I said, no, that's not, that I'll not be able to support that. Then I try to just see if I have access to the other items in the context at the API level. And that was kind of a gotcha moment. So now that's all.
Are there any questions? I've got the question window open here if there's any questions or anything. If not, thank you very much, Wagner. And that is a really insightful talk. There was a lot of things I actually learned tonight on that, especially I haven't used the Visual Studio Code for API management that much. I've started using the REST extension and calling APIs and stuff from that, but not as much as you did with the API management stuff.
It's a life-saving.
Yes, I can see that. Thank you very much for everyone that attended, and we will have the recording up shortly. So thank you very much, and I think that pretty much takes care of this evening, and thank you very much again for attending.
Cool. Thanks, guys. Thanks, everyone. See you next week or next month.
Yeah. Good night, everyone.